Alright, so for this question, we're given a little word problem. We actually have to come up with the absolute value equation first. So the example says, a computerized process controls the amount of fish that is placed in a can. The computer program sets the ideal mass at 170 grams, but allows for plus or minus 6 grams. Solve using an absolute value equation for the max and min mass of fish in a can. Now I'm sure most of us can just look at that, use a number line, and solve this, okay? But I want us to set up an absolute value equation. But just to show you, we all know that we could go 170. Well, if we add 6, we're at 176. We subtract 6, we know that we are at 164. So that's really our min, that's our max. So that can be helpful in a test, though, that when we go to solve, we know we have to use absolute value equations because that's what we're being assessed on. But you can always use this as a check to know, are the answers I'm getting in the end right or wrong? Okay, because this is pretty straightforward. But we want to use an absolute value equation. So what we don't know, remember when we're solving an equation, is what we don't know. And what we don't know, we'll call it M because we're dealing with mass. We don't know the mass of any specific can. Okay? Because each can is going to say 170 grams on it. They're not going to make a different label for each can determined by the weight that's in it. They're all just going to say that it's 170 grams. But each can you pick off the shelf might not be 170 grams. So we don't actually know the mass of it unless we were to actually weigh it. So using the information that we have to come up with an absolute value equation. So mass, okay, subtract 170 will equal 6. Okay. Well, that doesn't really make quite sense yet, right? Because what if the mass is less than 170? If the mass of this can was less than 170, subtract 170 wouldn't give us a positive number. Well, how we solve that problem is we put this side inside absolute value signs. Because now, no matter what the mass is in here, whether it's less than 170 or greater than 170, when we get our answer, we take the absolute value of it. It'll always be positive. Okay? So we don't have to write positive or negative 6 over here. We can just write 6 because we know that the difference, the maximum difference, will be 6 all the time. Okay? So if this is a maximum filled up can, it'll be 6. And if it's a minimum filled up can, it'll be 6 because we are taking the absolute value of it. So now we just have to finish this up by solving. Okay, and remember, we know we have two cases to deal with. M minus 170 equals 60, and negative M minus 170 equals 6. Okay, add 170 to each side, and we will get M equals 176. That is going to be our max, just like we said here. And over here, we'll get negative M plus 170 equals 6. And I'm running out of room, so I'm not going to show you all the work, but you know all the work to go with it. Subtract 170 from each side. You will get negative 164. But then we have to divide by a negative because there's this negative here on the M. And we do that, and we know that we'll get M equals positive 164. So that's our minimum. Okay, so the max of a can will be 176 grams, and the minimum in a can will be 164 grams. Okay, so that's just another example. This one we had to come up with our own absolute value, but really not that difficult. Now let's just continue on looking at some more examples. Alright, so example 3. Example 3, now that we know the basis of an absolute value equation, and the fact that the inside part could be a positive x plus 5 or negative x plus 5. Okay, so this entire thing is either positive or negative. Okay, so we really have to solve twice. The next part to it, the part we didn't look at the first two examples, because I just wanted to make sure that we got the basis down in the first two, is the answers that we're getting, are they actual answers? Will they work in the domain of the function? Okay, and we'll see why as we go through this example. So the first part of this, we have to represent this absolute value part as a piecewise function. Okay, so x plus 5. Well, we know now with piecewise, x plus 5 can either be positive or that whole thing could be negative, because when we take the absolute value of it, it's going to be positive. Okay, this is if, and this is also if it's in a certain domain. Okay, if you don't remember how, remember you just take the inside, that it equals 0. You get x equals negative 5. Okay, and then you could do your line and test. So there's negative 5. Pick a point over here and test it. If it comes out positive, then that's the domain for this part. If it comes out negative, then that's the domain for this part. Okay, if we plug in a point over here, obviously sub in negative 4. Negative 4 would be on this side. Negative 4 plus 5 would be a positive 1. So that means that on our domain, this is positive if x is greater than or equal to negative 5. Okay, and if x is less than negative 5, then this will equal a negative number, and we have to times by that negative. Okay, so this is going to come into play when we look at our answers. Okay, so now let's go ahead and solve each of these. Okay, so positive x plus 5 equals 4x minus 1, and negative x plus 5 equals 4x plus 1. Okay, so let's solve each of these. Let's go, it doesn't matter which way we go, minus a 4x minus a 5 from each side. Okay, so I'll end up with negative 3x, and I'll end up with equals negative 6. So I end up with x equals 2. Okay, now what we have to do now is look, x equals 2. Okay, when we pulled out the inside part of the absolute, we said it was positive. Okay, what we have to do now is look at this x equals 2 and look, does that fit in this domain? Because for this domain, we said this has to be positive. If x is not within this domain, then we can't do this. Okay, this is not an answer. So we look now, and we go, is positive 2 greater than negative 5? Well, yes, it is. Okay, so we know that one's right. Because x is greater than or equal to negative 5 for that domain, so we know it's right. Now we look over here at this one, we end up with negative x negative 5 equals 4x plus 1. Okay, let's just do the same method, subtract 4x from each side, add 5 to each side. Okay, what I end up with then is, that's gone, I end up with negative 5x, and sorry if anyone else has noticed my mistake yet, that was supposed to be a negative 1 in here, okay, because I know I should end up with a positive 4 there. Okay, divide each side by negative 5, we get x equals negative 4/5. So now we have to look. Here was our domain. Is negative 4/5 less than negative 5? No, it's not. Negative 4/5 is not less than negative 5, so that is not an answer. Okay, so we only have one answer. Okay, this is our only answer to this problem, and the reason this one isn't is x is less than negative 5. This is not within that domain, so it's not an answer. Alright, next example, example 4. The first thing we always do is, if you think back to radical equations, was we wanted to isolate the radical. Well, the same idea goes for absolute values. What we want to do first is always isolate this. So get this absolute value part by itself. So the first thing we have to do is get rid of this positive 9. So we have to move it over to the other side. So let's go ahead and do that. Okay, so we're still left with the 4x minus 5 on this side. Okay, and on the other side, because we subtracted 9 from each side, we're left with negative 7. Okay, now look at that for a second. Now, when I tell you that there is no answer to this, can you tell me why? Well, the reason there is no answer to this equation is that the absolute value of something can never be negative. Okay, it doesn't matter what's in here. Once we take the absolute value of it, it's going to be positive, so it can't equal a negative number. Now, don't get that confused with the fact that whatever's inside here can be negative. There can be a negative number inside of here. Okay, and if you think of your piecewise functions, that's what a piecewise function is. The piecewise function is saying that what's inside of here can be negative, but once we bring it out, it can't, and that's why we multiply by that negative. Okay, so the answer to this question is, we just say it's an empty set. Okay, and this just means empty set, which means there's no answer, there's no solutions to it. Okay, and the reason for that, like I said before, is because the absolute value can't be negative. Okay, so this one's done. Okay, our answer is right here. It's an empty set, and the reason for that is because the absolute value cannot be a negative. Alright, one last example here. We've got the absolute